Everyone, welcome to meeting. What meeting number now? 4. I'll assume 4. Let's go with 4 until further notice. Although Danny will probably have the actual correct one in the title of the YouTube video. Anyway, welcome to this this week's Big Video meeting. Today it's going to be me, Philip Matthew. I'm going to be talking to you guys. I'm going to be talking to you all about just a quick introduction to how machine learning works. So first things first. Work properly. You're going to I will talk to all 2 of you. First things first, a little bit about me. Double major in computer science and applied math. And community I also work with some computational sensing lab and very specific with something like computer vision, combined with AI, and but if you honestly don't like talking about myself too much, if you guys want to know anything more, just ask me.
I would like to know something more.
Okay, what would you like to know, Sloan?
What is your favorite color for that?
So favorite color? Favorite color is something either black or blue. One of the 2.
I thought you were just gonna say black.
Well, I mean, I lean towards black, but yeah, anyway. That aside, the admit button. Also, the admit button. That's going to be recording as well, sorry. Anyway, just to preface it with this, I was assuming there would be more people, so this question would be kind of better to pose to the audience, but I'll pose it to you anyway, and I guess if you're on Zoom, answer via Zoom. But what is learning? How would you define the idea of learning? I'll wait for responses, and we've got time, so do not think I won't wait here for 10 minutes.
You will, he's not lying.
Yeah. Yeah. For those on Zoom, if you didn't get
Oh, we got the chat.
you got a response. Someone's awake. Understanding foreign new concepts, finding trends in past data, and applying them to future data. Continue. Okay, yeah, I like both of those. I do like both of those. Don't close it out or wait for the responses. You can move it over one. I mean, they're not seeing the chat. Like it's not like a screen share. They're not screen sharing the chat. Just hold that. Do that. Yeah. Anyone have any other answers? Anyone in person? Okay. So okay. Why is it that whenever I present it's always silence? Anyway, so with that said, I'll just take the silence as no one has any other ideas.
Oh, now.
Anyway, so that's it. Yeah, I guess John, that would be a really. I'm going to stick to your definition. So we can move to the next slide, please. Learning itself is a process, and it does involve finding, taking existing piece of data and using it to make predictions, finding trends and using it to make predictions out of new data. Specifically, the way I like to think of it is as follows. So the context that's best used to frame this would be assuming that, or thinking of like trying to teach like a baby what like a zebra is or something like that. So you'd start by showing them a picture, observing new data. So show them a picture of a zebra and be like, hey, that's a zebra, right? Then that gives them some prior knowledge of looking at a picture of a zebra and going, oh, that's a zebra. So then they would start, whenever they next see a picture of a zebra that's like, a different angle and stuff, they'd be like, oh, okay, well, I know in the past that something that looked like this was a zebra. Therefore, I'm going to assume that this is a zebra. Then you ask someone, hey, is that a zebra? You check how correct you are. And they either say, yeah, that's a zebra, congrats, you know what a zebra looks like. Or they say, no, dude, that's a horse. And he's like, okay, well, I messed up. And you try again. And you keep doing this process, you keep trying until eventually you're able to come to a conclusion at which you're like sufficiently correct, at which point you've understood what a zebra, you understand like the concept you're trying to learn. In this case, it would be understanding what a zebra looks like. So similarly, machine learning works in that way. So machine learning works in that way. Specifically in that learning process, one of the main things that we were doing was we were trying to learn the rules that came out of, or that govern how you assign labels. So traditionally, when you're programming something, you are defining the rules for your algorithm, and you give the program data, and then it takes all of that and it produces some sort of answer, right? It tells you, given 2 things, like, what's one common, like given like a number, like should I print fizz buzz or fizz buzz? If you guys are going through interviews, you'll know how painful that process is. Or like, another common thing would be something like, simulating a rock, paper, scissors game, right? You know the rules of rock, paper, scissors, those are what you program. You know the data, which would be the user input, right? And then you produce some sort of answer, like whether the computer chose rock or scissors, and basically that would say whether or not the person won that round. That's what traditional programming is. Machine learning, on the other hand, thank you. Machine learning, on the other hand, is a lot more. What's the term? It's a lot different because you start with the answer. So you have some data, and you know what the answer is. You know basically what the inputs are and what the outputs are. You have no idea what the rules are. You're trying to figure those out. And so what machine learning algorithms do is what they aim to do specifically is given some data, they try to take the answers to the questions you're asking with that data, they try to predict what the rules are, what the trends are in this data, and what's coming out. So next slide. So with that, there's two different types of machine learning. Specifically, you've got supervised learning and unsupervised learning. So supervised learning is something like the zebra example I talked about earlier, where you're telling someone, you specifically know your labels and you teach them to the you teach them to the model. So in our case specifically, you provide the model with like inputs and like labeled inputs, and you tell it, okay, this input should have this label, this kind of input should have this label, and it'll sort of build up the trends and learn how I can go about labeling things based on what I've seen in the past. Unsupervised learning is a little different. You only give it input data and you have no idea. The whole idea with unsupervised learning, if you admit voting, so
Working on it.
thank you. The whole idea with unsupervised learning is specifically to figure out what sort of categories exist in a given data set. So if I have some data, and let's say that it's clustered in certain ways, and it's like arranged in a certain way, what would the labels be? Like if I had to assign labels to it, how would I go about doing that? That's one setting of unsupervised learning. Another setting is trying to play a game, right? What sort of rules what sort of path principles do I need to follow in order to succeed at this game? That's where unsupervised learning succeeds best, where you know the input, but you just don't know, you can't really specifically nail down the output. You don't know exactly what you're trying to get at, but you know more or less like a general idea of it. So you help it define the specific rules that will get you there. And then as I mentioned earlier, supervised learning specifically, you help to learn the specific rules that will figure out whether or not something has one label or the other, or whether it has one value assigned to it or another. Right. Next slide. And so for the rest of the meeting, because this was actually a relatively short presentation, and I realize that works quite well, given attendance, but with that said, we're going to try an example of both of them. So I'll give you guys a couple minutes. Zoom chat feed, please feel free to join in as well. And essentially, I'll be starting with a supervised learning example of given a couple pictures of a guitar, how would you classify it? How would you look at the picture and be able to identify, oh, the thing in that picture is if you guys have any ideas, please throw it into the chat or please let me know two of you, and we'll see what we can get at.
It's like a pear-like shape.
What?
Looks kind of like a pear.
Looks kind of like a pear. Yeah, no, I get what you mean. Yeah, we'll go with that, sure. These ones, on the side, if you see Prince's guitar, it's absolutely not like that, but I'll go with that. It should be fun just to get that. Anyway, that one does work for the sake of these pictures. Yeah, so a pear-like shape. Yep. Yep. Sure. Yeah, the general shape of like line and then like some sort of like other like the body. That works. So Jeff.
Right, let's go to our lovely viewers at home.
6-string instrument has body, neck, and head. Yeah, it's called a head. Although I call it headstock. Tuning pins on top can have electric controls, frets. Right, yeah, so there are a lot of different variations, right, as we know. But what we're trying to do, and what the machine learning model is trying to do, is find something that generally works. Right, so yeah, it can have electric controls, but you can't really use that to figure out whether or not a guitar is a guitar, or like a picture contains a guitar, right? Because again, you can get an acoustic and you can't say that one doesn't have electric controls, but okay, very clearly it's guitar. However, So what you're trying to go is you're going for general rules, right? And that's one of those things with machine learning models. Sometimes when you're training them, which we'll learn about next meeting, because that's just more of an involved like math way. Like basically the specifics of doing machine learning is kind of involved in terms of the math. So I wanted to put that all in one meeting so you guys weren't just completely confused. And I wanted this one to be somewhat a gentle introduction. So yeah, but in general, when you are using machine learning models, oftentimes they can end up being way too specific. They'll end up getting really stuck on, oh, it'll have like a specific control knob in this position or something like that. And what we want is to not have that happen. We want something general. So things like electric control knobs work. Things like 6-string instruments, while it does work in this case, actually for reference, you can have guitars with 9 strings. You can actually have guitars with 12 strings. Well, Jimmy Page famously played 12 strings. But point is that like some of these are good examples, like having a body, neck, and head and stuff, and the tuning pegs. But things like electric controls and even frets actually are, in my opinion, not great because guitars are very often actually fretless, and the electric controls are specific to one type of guitar. Any other like general, broad sort of traits that guitars seem to share? That you guys can think of? I'll give you like 2 minutes for it, so, and if not, we'll just drop it. That was not 2 minutes, or whatever, I'm assuming silence is silence. So yeah, well, I guess that would be good, that's a good then thing for supervised classification, right? So if it has like this general pear shape, it's got like a neck, it's got the headstock somewhere, and I'll just go with the single picture, it's got like 6 strings, then we can say that, okay, this thing is most likely a guitar, right? That's probably a good idea of supervised learning, trying to figure out these trends or these rules that'll help you figure out whether or not something has a specific labeling. So on next slide, please, and those are tracking over half side, or just minimize it because you'll have to pull it. Now, as for unsupervised learning, what we're going to do, oh, by the way, sorry, so for this previous slide, this specific example of type of supervised learning we were doing was called classification. Supervised learning, as far as I can tell, we split into like 2 different categories, like classification and regression. So am I missing anything?
Not really.
Yeah, so it's classification or regression. Classification is specifically, hey, what label does this thing have? Regression is what sort of values, or regression would be something like a continuous scale. So like, hey, if I have a house, given all these attributes, what's its price? And like obviously that can't just be like 1, 2, or 3 or whatever. That's like some real number, usually in 100 case. But regression is trying to predict some sort of continuous output, but classification is some sort of discrete output. With that said, as I said earlier, we're going to be moving on to now unsupervised learning. Specifically, this form of unsupervised learning we're going to be doing is called clustering. And so what clustering aims to do is essentially try and, given a bunch of data points, try and find how they're clustered. So like where, like basically try and identify which, how many different groups of data there are, and like, what those clusters, like some sort of representation of these clusters. So in this specific scenario, we're going to try and be clustering, or again, a better word, we're going to try and categorizing these instruments. So again, Zoom chat people here, how would you go about categorizing these instruments? What sort of rules would you follow in order to figure out, in order to categorize these instruments somehow? And also, may I add, for any of the music major selections you bring by people here, I do not care about the specific musical classifications of these instruments. Frankly, all of that is absolutely wrong. Just if given all these, okay, it's not bunk. It's just kind of like every instrument can fit in like 38 different categories because of like the way that people use them.
That's not always true. A piano is not a woodwind.
No, but a piano is a percussion instrument and a string instrument.
That is true.
Just because you tap the keys. But I would argue that like most string instruments are quite different from a piano. So anyway, point aside. Not necessarily. So classification of guitars is just figuring out what traits belong to a guitar. Clustering is trying to figure out, given a bunch of these things, how can we organize them such that you have groups with common traits, right? So you can think of classification as more focused. It's more trying to figure out, I know what I'm looking for, what makes it, have that, what makes it be what I'm looking for. So in our case, I know I'm trying to figure out whether or not this thing's a guitar. What makes it a guitar? In this case, we have a bunch of different instruments that, for our intents and purposes, we have no idea what they are. I mean, I know we do, but like assume you're a computer, you've never seen these before. You have no idea what these things are. And so you're trying to figure out, okay, well, I don't know what they are, but I know that this one and this one look similar, therefore they are probably like, the same label. This one and this one look similar, okay, they're probably the same label, something like that. And so that's what clustering is. It's basically trying to find those commonalities and grouping data points that way. Whereas classification is more just, I know what I'm looking for, what makes that thing, special. Basically. So with that said, how would you go about clustering these instruments or, categorizing them in some way? Grass would be its own category. That's exactly why I didn't want to follow the instruments thing. Saxophones aren't grass instruments. It's stupid, but they're not.
Out of curiosity, which category are they?
I will explain that later because it actually kind of.
Oh, so that's spoiler, okay.
Okay, it's somewhat of a spoiler, but it's why I chose a saxophone as opposed to a trumpet. But yeah, saxophone aren't actually grass instruments. I'm sorry to tell you. Yeah. Anyone from Zoom, feel free to chime in as well. I'll see you guys obviously. Cool. Yeah, that's a possibility. Saxophone and clarinet share a similar mouthpiece, has reed and ligature. Yeah, that also works. So I like both of them, right? Because you actually have two different examples of how clustering actually does work in the real world. So you have what Richard says, which is more in line with what we would do as humans, which is like, very clearly this mouthpiece, they look very similar. So we're just going to go along and say, okay, these two are probably in the same category, right? Because we have what was sorry. Secreting. Yeah, I'm gonna forget that. I'm sorry, I'm bad at this. But secreting. You said, okay, well, all these are colored black, so let's just throw them all together, right? Both of those are valid, and both of those are exactly how clustering will work in real use cases of it. However, it's very clear which one we prefer, right? From a human standpoint, it's kind of like, okay, but from a human standpoint, you look at the saxophone and the clarinet, and you're like, okay, yeah, those two get shut together. And you don't go just by the color of the instrument, right? However, since both of those are valid, one of the things that is somewhat unique to unsupervised learning is that trying to make sure that your computer doesn't, it's not actually. One thing that is somewhat of a thing you have to deal with machine learning algorithms in general is, again, trying to make sure that the computer doesn't go down the wrong path when doing all of this learning is a very important thing. Like trying to make sure that your computer chooses like the right category or chooses like useful categories, I guess, is an important thing, and it's one of the main issues when you're trying to design some sort of learning algorithm is how do I encourage it to choose to cluster things in a way that's useful to me instead of just wildly going. And that's something we might discuss next meeting. If not, it's something I'll probably discuss at some point. But there are ways of doing it. It's just they're a little involved with the math, so I'm gonna go with that. But with that said, okay, so we can let's continue trying to cluster these things. So yeah, we can say that there's similar mouthpieces, so sure, saxophone and clarinet get shoved together. How else would we go about this? Like what other clusters could we create?
And some of them are like static, some of them are like a piano and like concerts.
Yeah, sure. Yep. So yeah.
Like they're black color.
Yeah, that's pretty just like that actually.
Oh.
No, you're good. But yeah, we could, so yeah, we can definitely go by, whether or not they're standing or not, specifically whether or not there's some sort of like, I guess, feet.
Yeah.
So like, the drum set and the piano both have feet. And like, yeah, I mean, I guess like, I'm gonna let the guitar stuff be trivial with this, like, kind of already did that. Although that's a bass, it's not a guitar. Basses are different there, but you can see that there's a very clear way. There's actually not even just a very clear way. There's a very clear way that we as students would cluster these things. So as we said, saxophone, clarinet both go together. They have similar mouthpieces. And the reason that I didn't actually tell you what category saxophones go into is because saxophones are technically a woodwind instrument.
Yes.
Because they use a reed. So the mouthpiece is not made fully of metal. It's got a reed there. I was in band at one point and I learned how to play clarinet in third grade and never learned again. But I do remember this being harped on very much is that, yes, saxophone and clarinet, they both are woodwind instruments, but they both work by a reed. Then,
Clarinet solo went.
what?
Bill clarinet solo went.
Dude, I don't remember how to play. I'm pretty good guitaring and so I'm not entertaining all, I guess, but, you know. As for the rest of them, guitar and bass, obviously you can throw them together because if you want to start a rock band, you can put those in. You need guitarists and bassists, although bassists are idiots anyway. And then in terms of, the remaining two, you could just say, hey, those are the remaining two, we're gonna put them together. But also in terms of trying to find an actual like complement. Actually between them, both pianos, both the piano and the drum set are percussion instruments, technically, so you can classify them that way. However, as mentioned earlier, there are other ways of doing it. So if I wanted to say, okay, well, let's classify them differently. I could classify them, let's say, which ones are like, we can go by popularity, right? Which ones are more popular, right? We're gonna classify like popular instruments or relatively unpopular. Now, I picked a lot of popular instruments here. I think all these relatively popular instruments for play, but so you can close up chat, by the way. Yeah,
I got it.
when your break turns on.
And I'm getting on it.
Okay, but with that said, we could say something like, okay, well, guitar and piano are probably by far and away, I would argue, the most popular instruments here, right? So you could put those, and let's say drums, because again, a lot of people play drums, club those under like popular, and then like bass and saxophone and clarinet relatively. Again, I know bass and clarinet probably are less popular than those three. I don't know saxophone because it does seem like a lot of people play saxophone because like everyone likes jazz. But like in general, you could probably say that those three would be like the less popular instruments, and you can categorize it that. Similarly, you could also just go by a different way of measuring string instruments. You could say, okay, well, pianos are actually they work by strings, whacking a string. So therefore, they belong with guitars and basses, and then don't change the rest of it. So then drums are on their own, and clarinets and saxophones together. As mentioned earlier, we could also go by colors. So we could say, oh, black instruments are one thing, the brass colored instrument is one thing, and the guitar is its own. Right? There are many different ways in which we can go about classifying or categorizing these images. Sorry, and all of them are valid ways of classifying as long as there's some sort of rationale. They're all valid class or categorization methods. Not all of them are useful, as we mentioned. And so one of the things we're going about next meeting is we're going to be talking about specifically, first of all, the math behind all of this and how you make the computer follow the machine learning algorithms. And then moreover, once we've gotten that part out of the way, how we can make it so that these algorithms actually learn something useful. And so with that, next slide. With that, actually, before it's a thank you slide, I would like to take a half second to talk about some of the applications of machine learning. I'm sure we're all familiar with the because like this has become big in the news, but there's like stuff like self-driving cars. I didn't actually know if there was a company other than Tesla that was working on the good self-driving. I should have put Waymo because like fuck Elon Musk. But
yeah, isn't Apple like doing self-driving cars now?
Yeah, but also Apple. Okay. If there are companies that are just like terrible for the consumer, Apple's one of them. They make decent products, but their policies are terrible. Anyway, I don't know. My mom has a Tesla, that's why I put it there because I know that's a self-driving thing. So I just kind of went with that. I should have put Google now that I think about it. Even though they're kind of evil as well. Anyway, so yeah, self-driving vehicles, you got Tesla. There's all you can also use AI to predict stock market trends. See way too many fellow classmates and stuff being like, yo, dude, I'm going to do this new cool project where I predict the stock market to predict my investment portfolio. And like, while I've become personally desensitized to this whole thing, but it's an extraordinarily useful field in terms of managing your own money. Also has its downsides of being used to inflate the profits of billionaires, but frankly, that's its own deal. Use it for your own good and distribute it. Then we have some other fields like machine translation, so specifically using AI to try and figure out, hey, given a text in English, can I convert it to a text in Hindi or Japanese or Klingon or some fictional language like that? It could be any sort of language whatsoever. On the note of languages, you can also do code completion. I'm sure many of us who are CS are familiar with or have heard of GitHub CoPilot, where GitHub has produced some sort of tool that'll write whole functions for you. My personal 2 cents, don't use it too much because got some security issues from what I remember, so we can go more.
I mean, if you're working in like a professional organization, especially large companies, a lot of them have like fail safes against that, mainly using like work repositories and other sort of measures to get.
Yeah. No,
I wouldn't say you can get out of using it if you're.
No, Copilot.
Oh, CoPilot, I don't know. We don't use CoPilot. We use
Okay,
like-
yeah, so for those who don't know, Copilot is basically, if you guys have ever used an IDE where it like auto completes your code for you, but like just complete the line for you. Yeah, GitHub will do that where you can type like define factorial of n and it will complete the whole function for you with comments and stuff. It's kind of cool. It's also kind of not great because it's kind of insecure. I think some things where like you would have like code completion for like ingesting user input and then that wouldn't be sanitized, so you could have your website get SQL injected. For those who don't know what that is, basically someone could just type code into a text box and the website will run that code. So they could have it write like print insert user password and it will print their password. And it's like, okay, well, this is not good. You know, you can have things like that. That's not ideal, right?
I ingest users.
But yeah, in general, GitHub Copilot is pretty promising, but they do need to fix a lot of the issues in there. And the last one, which I saved for last because it's one of the things that I've actually worked on specifically is automated disease diagnosis, where we're using a lot of machine learning. I mean, how machine learning is it's a huge field. If you guys look at a lot of like the recent research coming out of, I'm going to show like specifically Johns Hopkins' biomedical engineering lab or biomedical engineering department. A lot of it is focused on AI applications to healthcare in general to try and either speed things up or try and diagnose diseases. And so one of the things that we do is we'll have, if you think of things like any sort of image scan that's taken, so whether it be like a brain scan or like an X-ray or just a picture of like a rash or lesion of some sort on the surface of your skin. There we have method, or actually like tumor images. I don't know if they're called X-rays. MRIs. MRIs is the term I was looking for, but like MRIs of like tumors and stuff. You'll take these images, you'll run them through some sort of machine learning model, and it'll be able to actually output. It'll be able to tell whether or not a certain individual has that disease or not. So it'll just diagnose them. But it can also diagnose severity. One of the models that I worked on specifically was designed not only to diagnose whether or not someone had diabetic retinopathy, which is like eye function decay due to diabetes blood cells, as we all know. But moreover, one of the specifically we tried to figure out what the severity of this diabetic retinopathy was and whether or not it was like something that you would have to refer them to like a more specialized doctor. That was a nice paper that we ended up getting published. But the point is that like there's lots of different applications in that field, and there's also just like significantly more than stuff we've written here. One thing is used to I actually didn't mention, which is pretty obvious and was in the news with Target, I believe, is trying to predict what someone's gonna buy. If you guys don't know the news article, it's actually kind of famous and it's kind of old now, right?
Oh, is this the one we're targeting?
Yeah. Don't reveal the big one yet. Don't reveal it yet. But like it's cool.
It was a while ago. I think
Yeah.
2015.
Yeah, 2015. It's basically Target had like a rudimentary. This was 2015 was before like a lot of like the newer stuff that we use, like the more complex models took off, I guess. But main thing, it used a lot simpler things, but they used a technique, some sort of machine learning model on patients like what or not patients, sorry, on what customers would buy. And so there was this one customer who would buy a lot of things that were associated with being pregnant. This lady then started getting ads for more things for for pregnant mothers. Turned out that she didn't tell her parents, and she was like, I don't know, I guess she wasn't lying or something.
Wait, I thought the story was that like she didn't know she was pregnant.
Oh yeah, no, it was that actually. Yeah, she didn't know she was pregnant. Yeah, I mean, she just happened to be buying things like that because I guess like hormones and stuff. Don't correct me if I'm wrong. I am but a man. I have no idea about how pregnancy works. But
You're canceled, Bill.
yeah, no, I'm getting canceled.
Already are.
Real talk though, if anyone does feel the attention, please. But point stands that like she would buy a lot of things that were common for pregnant mothers to buy, and then her parents got mad and were like, "What the heck? Why are you advertising things for pregnancy? My daughter." Got into the whole thing, and basically it turned out the daughter was actually pregnant. And Target had predicted it before the daughter had figured it out, or either the parents do. One of the two. But the point is that like it's very easy for you, given machine learning, for you to like figure out things that might seem crazy. I know a lot of people have this idea of like, that like, you know, when you're like, if you've ever had a situation where you're just talking about something to your friends, and then you look for Google and you see that like the next top result on Google, like the top thing for like your Google recommended is just that thing you were just talking about. And you may think, okay, they're listening to me on my microphone. On one hand, I don't know whether that's true or not, so don't actually quote me on me saying it's not true. But on the other hand, a lot of times for things like that, it's just Google knowing you very well. Because we've all used Google for so long. And even if we now say, hey, revoke my data time, they still have historic data. So they've still built some sort of profile with you. And they can be like, you know, like me, for example, like, yeah, it would be easy for them to predict because they can just be like, okay, well, you know, what was this guy talking about? Well, it's a Sunday. He's a huge Ravens fan. He also watches a lot of Formula One. Let's recommend him things about like, I don't know, Lewis Hamilton, or things about Lamar Jackson, like, you know, articles like that. And so if I just talk to my friends and say, I'm just talking to my friends about like, oh yeah, you know, Lamar Jackson has like this stat line that was like top, like, you know, that's gotta be like a historic stat or whatever, right? Look at my phone, first recommended. Lamar Jackson's stat line, new NFL record, or something like that. Right? Like you may think, okay, what the heck, they're just listening to our conversation. In reality, they're just kind of matching profile. And they have so much data on you that they're able to very, very, very closely figure out what you do. That's one of the downsides of machine learning that I don't know if we have time to talk about ever. But I know someone, and I will definitely pepper that in through whenever we speak about machine learning, because one of the major things is that the amount of data that the amount of data prediction, like very accurate predictions you actually can make with machine learning models, enables you to, in some ways, violate your privacy, just straight up violate their privacy. And there are a lot of efforts into making models that don't do that, but it's just a very, very, very fine balancing act you need to do whenever you're developing things that like are designed to, you know, profile user more stuff, like only taking the data that you need and considering even if you need data, whether or not it would be necessary, whether or not there's a way that you can do that. Because at a certain point, there is no need to start just figuring out whatever everyone's social security number and name is and stuff. But with all of that said, and with that cautionary tale, somber note to end on. Next slide. Yeah. Well, I'd like to say thank you guys all for coming. Hope to see more of you in person next time. I fully understand Zoom at this midterm, but I do prefer seeing you all in person. We're going to be talking about specific machine learning models next time. So yeah, if you guys have any questions, feel free to add me in Discord or just ask me now. But thank you all for coming, and we'll see you next week.